All right, let's look at the definition of transformations. All right, so F is a mapping from plane P to itself. It's called a transformation on P. If F is 1 to 1, or you can say injective, or and F is onto or surjective. Right. So remember that being 1 to 1. So this is what we need to show. In order to show that F is 1 to 1, we need to show that for all points, say A and B in the plane P, right? If F of A, so you apply F to a point A, and if you apply F to point B, they happen to be the same. Then this always implies that A has to be equal to B, right? So this is what you need to show when you try to establish that F is 1 to 1, and F is onto means that it hits everyone in the codomain. So for all point, say I'm gonna call it A prime in the codomain P. Right, codomain is this guy right here. So this is the domain, and that's codomain. Right, there's always a point, corresponding point. I'm gonna call it A in the domain P, such that F of A is exactly the same thing as A prime. Right? So that's what we need to show to establish that F is onto. Right? And if you have a transformation that preserves collinearity, so all the line is going to be mapped to the lines, then it's called a linear transformation. Right, so F preserves collinearity, then F is called linear. Right, and just one remark would be so you have a injective and surjective, so it's a bijection, 1 to 1 and onto, which means that we can find the inverse function, so F inverse. Right, as it turns out, F inverse is also 1 to 1 and onto, so therefore it is also a transformation. Right, so we're going to have to show, this is going to be a homework. So one of the problem is asking you to show that F inverse is automatically a transformation. All right, that's it. I hope that this was clear.